Okay, so I'm going to carry on and do hints for questions 11 and onwards. This one is an experiment to determine the Young's modulus. The Young's modulus, you should know, is stress over strain. You get that in the exam. It's often called something like E, Young's modulus E equals stress over strain. The things that you need to work out are what actually is the stress. Well, the stress is equal to the force over the area. It's like the pressure. It's kind of a measure of how much force you're putting on a wire and kind of its cross-sectional area. And the strain is the change in length divided by the original length. Okay, so what are we marking? Already working out the initial length of the wire. So we've got the initial length was measured. Slotted weights and known values are added. Well, this is going to give us the force. This is going to give us the tension, because this will give us the weight, and that weight there is also going to be the same as the tension in the string, which is going to be the tension here. So we'll have that. Each time the weight was added a new position on the marker. So we're also measuring delta x. We're going to get from here, aren't we? Delta x. So let's look at what we've actually got. Delta x, we've got x, we've got the force. We haven't got the cross-sectional area. So state the additional measurement would need to be taken, something which gives you the area. So what you're probably going to actually measure is the diameter. If you've got a cross-sectional wire here, you probably actually measure the diameter. That's what you measure. Measure the diameter with something like a micrometer or a vernier caliper. And describe a graphical method. Well, what you need again with the graph is something like y equals mx plus c. And we are going to try and work out what E is. So Young's modulus is equal to F over A, if you like, times X over delta X. So that should be enough for you to plot a couple of different things and work out how to get this. Now let's think about this. Yeah, I think you can do it. You really want the actual graphical method to give you E as the gradient. So you really want to rearrange that equation so you can get E as a gradient, which you should be able to do. Question 12, two trolleys A and B. This will be a conservation of momentum question. Conservation of momentum. Yeah, so you whack the hammer and a peg pops out and trolley A goes in this direction, trolley B goes in this direction. Explain why two trolleys move apart when the spring is released. Well, the actual reason they move apart, you've got to think of Newton's third law, which is equal and opposite forces. What happens if you've got trolley A pushing on trolley B and trolley B pushing on trolley A and they're both free to move? Explain which trolley will move off with the greatest speed. Mass of trolley A, okay, is 0.1. Well, you should know that the conservation of momentum means the mass of trolley A times the velocity of trolley A is going to be equal to the mass of trolley B times the velocity of trolley B. That should be enough. If you do 3 marks for that, that's crazy, really, when you think about it. Next question, projectiles. This looks interesting. Okay. So this is 20 meters per second and angle 75 degrees to the 75 degrees to the horizontal. And the other one is also 20 meters per second but it's only 15 degrees. Okay. So both balls reach child Q at the same time. Right. So what do you know? You know, the thing about this is, okay, so you've got the first throw. So you go throw 1 and throw 2. And so with throw 1, you've got the time 1 is the whole length of time. Actually, let's do the same colour as before. So this goes up, and so this is T1. And for the second throw, you've actually got to wait a small amount of time. You've got T, which we don't know what it is, plus T2. So T is the wait time, and then time 2 is the second throw time. So that's going to be, you'll be able to calculate this and that in the same way because you've got the same initial information. And then the only thing you need to do is say, okay, the difference between those two is going to be the wait time. So you should be able to do that. You should be able to do that okay. What you're going to basically do in these types of questions, you're going to split into the vertical and horizontal, and then you're going to measure the time due to the vertical, and then you're going to use that same time to say that it's the same as the horizontal time. And you should be able to work it out from there. Okay, question number 14. This is a musical instrument, a triangle. And the interesting thing about this is that the center of gravity is not quite in line with the top there. There's a certain distance. Its actual size, so you're supposed to measure this, and I'm guessing if you printed this out, this would be sort of like about 0.5 centimeters, maybe 1 centimeter, I don't know. It's like hard to tell, I'm on an iPad. But you will, first of all, you've got to state what that is. You should be able to work out through definitions, center of gravity, what that is. I'm not going to cover that, that's bookwork. And this one is, you've got the mass and you've got the moment. Well, we know that the moment is the is equal to the force times the distance about any particular. When they say about, it means that's the pivot point, force times distance. And actually it's the perpendicular distance. So let's say we've got O here, and we've got the centre of gravity there, and this is, the force is going down, and the force of that is the weight, and then this distance is whatever it is. Okay, how do we work out the weight? Well, we've got the mass there. Okay, the triangle is now suspended by a thread. Explain why the triangle settles in a position where the base is no longer horizontal. Well, if it's free to move, then the centre of gravity will always be directly below the point of suspension, because if it isn't directly below, then there will be a moment. So the moment, the turning effect, will turn it until it does end up directly below. You kind of know that. This question 15. Okay, so that's a vector addition question. You should be able to do that just by drawing. Draw a vector diagram to determine the resultant force. Great. Okay, so you put the right lengths in, 9.5 times 10 to the 4 and 1.2 times 10 to the 5, and you put the right angles in, and then you work out very briefly. If you've got this like this, and you've got the other one like this, so these are the two forces. So you've got to think, well, how do we do these, guys? Well, how do we do those? Well, this is a nice thing to do here. We can actually move this, and we move this one to this like that. I won't give it away, but you go from the something like that, the nose of one to the tail of the other, and the nose of this one to the tail of that one, and that's the resultant one. And you've got to be able to do that accurately and work that out. So the ship has a velocity of 4 meters per second in the direction of the 1.2 times 10. Okay. Calculate the rate at which work is done. Okay, so work being done, you've got to remember rate at work being done is the power. And power is equal to force times velocity, or power is equal to energy over time. Energy, work done, force times distance over time. A few different ways of looking at it there. This tugboat has 2 engines, each of power 950 kilowatts. Calculate the efficiency. Okay, so you know that if it's got this tugboat, okay, yeah, the tugboat that provides this force. So it's got 2 engines, so that's the power that it's using up times 2, and then you work out the rate at which it's doing the work, or the power that's useful, which you've just calculated here. Okay, right, next question. You're throwing a ball upwards. Okay, I love these questions because you've got to work out what's actually going on. Describe the motion of the ball between times 0 and t3. Okay, so the thing to do at time 0, what velocity has it got? It's got v1. So v1, so at t0, it's got v1 velocity. At t1, what velocity has it got? It's got 0 velocity. At t2, so you carry on going and just work out what's going on here, and then you should be able to then use that to then describe what must be happening. And describing the motion, you've got the obvious thing is like, well, it's thrown upwards, and then it goes through 0 velocity, which we know is something kind of special. It happens at a certain time. And then it hits the ground here, and then you need to talk about the direction as well, the direction of the velocity. That's kind of important, what's going on there. The gradient is always the same, because the only thing that it's being influenced by is acceleration due to gravity. How many marks do you get? 4 marks for that. Okay. Now, you draw an acceleration time graph on the axis below for the motion of the ball from time. Okay. Acceleration time graph. This is interesting. A bit of a trick thing to remember here is that acceleration is the gradient of the velocity time graph. So it's the change of velocity over the change in time. And notice the gradient does not change. The slope, if you ignore this bit, which it does say to ignore, ignore any temporary change, it's the slope. The slope's always the same. 2 marks for that bit. Student investigating a spring. Okay, with this one, weight of the disc. Well, this is calculate the volume and density. And then the volume and the density, you can work out the mass. And then the mass times the acceleration due to gravity, 9.81 newtons for every kilogram, will give you the answer. 4 marks for that, so that's very easy. Easy marks. Student drops the disc from a height of 0.3 meters onto a spring. The original length of the spring, I say, So you've got maximum compression. So you've got, this is the change here. And you've got a height there. Okay, brilliant. So with this, you've got to calculate the change in gravitational potential energy of the disk between when it's released and when the spring has maximum compression. So the thing is here, you've got to work out that it's got a certain amount of gravitational potential energy now due to the height. So GP equals kind of mgh. And it loses mg delta h, whatever its height changes by, that's what it loses. But it gains, well, first of all, it says calculate the change in gravitational potential energy. Hence calculate the maximum force that the disk exerts on the spring at maximum compression. Okay, so what it's doing then is it's saying, okay, how can you work out the maximum force? Well, use Hooke's law, F equals minus kx, and you can work. You know that the what it's actually doing when it's compressing a spring, it's sort of using up the gravitational potential energy, which is sort of turned into kinetic energy. And so you could probably, if you kind of know what's going on in terms of the relationship between the elastic energy, which you probably know in your exam formulas, which is, what is it? So basically the force times the distance. So it's actually force, or the maximum force divided by 2 times the extension. You can work out what's going on there. Hence determine the stiffness of the spring. So you can then work back, if you've got force, then to work out this K. Okay. Is this the last question? Maybe not. 18. Kevlar is a modern lightweight material. Due to its physical properties, it's being used to replace nylon steel. Okay. So what you're looking for this is stress. If something can actually withstand a lot of stress before it breaks, and these are the breaking points, then that's really cool. So that means it's incredibly good at, stress is related to the force, isn't it? So the force over area. So assuming that the area of the cross-sectional area of a Kevlar cable and nylon cable are the same, the only difference is if it can get to a higher force before it breaks, then it can withstand a higher tension than nylon, which is going to break around about there. Explain 2 advantages using Kevlar cables compared to using nylon. So you should be able to work that out. Photograph shows a machine used for the seabed. Okay. Got to read a little bit about this. You're talking about material must withstand the large pressure of the seabed, yet be light enough to lift out of the water. Density of Kevlar, density of steel. Deduce whether steel or Kevlar is more suitable to use in the outer casing of a communication cable. Interesting. Well, you've got to sort of work that out. Okay. Due to the effects of upthrust, the apparent weight of a cable in seawater is less than it is in air. Calculate the apparent weight. So the apparent weight is going to, okay. So basically you've got the actual weight here, and then you've got the upthrust. So you've got to calculate that. I think that's more or less it for this question. Question 19. Okay, nice one. Draw a free body force diagram for the yo-yo when the train is accelerating. Okay, so you've got to work out what's actually going on. Well, what's happening? you've got to just think of the forces that are actually on the yo-yo. You'll always have the weight and the other forces. Okay, well, what's actually going on? You have to be able to, you know, if it's an angle, something's causing it to go at an angle, so you've got to work out what's going on. And the train is accelerating. Okay. Calculate the acceleration of the train by resolving horizontally and vertically for the forces on the yo-yo. Tells you the mass and tells you the angle, so it works out the acceleration of the train. Okay. So, the thing to remember when it says resolve horizontally and vertically, basically, you should be able to work out that it's not moving up or down, so the vertical components of the forces, I don't want to draw them in because it'll give it away, but vertically the sum of the forces is equal to MA equals 0, and you're going to have a component of the weight obviously and a component of the acceleration there at an angle. And horizontally you're interested in finding the acceleration of the train, so is equal to the mass times the acceleration of the train. So horizontally the acceleration of the yo-yo, and you can work that out. I think that's about it. Oh, discuss whether the string could ever become completely horizontal or completely vertical while the train is accelerating. That's 6 marks. Wow. So the sort of things you've got to think about is, if it was completely horizontal, what would that mean? So similarly, so discuss whether, so say, let's say it was, what would that mean? Let's say it was completely vertical, what would that mean? Okay, we assume that it won't be able to, because that's why we're asking the question, but I want you to sort of work out the physics for that. And that's enough.